So this is the corner of one of our hectares that we've been mapping since the 70s. And you can see that, there are some fallen trees here that fell over naturally. It was probably a storm event. You can see the leaves are still on the tree, so it happens during this growing season. When you have really big trees take out other big trees, and you get a fairly large gap. And that's typical of old growth, right? So old growth forests, the gap dynamics are such that the size of the disturbance is sufficient for the trees that are waiting in the understory, including the oaks, to be able to make it up into the canopy. So here's a chestnut oak, for example, that was in the understory. Now it's got blue sky above it, and it'll probably be the tree that comes up into this gap. There are other trees that are competing as well in here, understory trees, and at the end of the game, there'll be a few winners, and other species will settle back down. For example, the sassafras. What we've been able to map over the last 50 years, you can see sassafras just wells up into these gaps, and then as the light closes back over, they just settle back down again. Sassafras is an example of a tree that is basically a root system with temporary above ground manifestations. Rarely does a tree ever, like this sassafras, rarely does it ever get up into the canopy. This one might, and it might not, but the individual lives on in the roots.
And so it seems like you're really putting a lot of focus in these understudied clonal species.
Yeah, because if you think about, what does it take to survive in this type of soil environment? Well, it's all about what's going on below ground, right? It's all about roots and rhizomes and below ground processes. Those fungal interactions I was just talking about, very, very important. But it's the trees that are able to persist are the ones that are able to maintain these underground structures that can keep producing above ground shoots over time. And that's an adaptation for fire. Once upon a time, there was probably more fire in this landscape than there is now. We don't allow any fire, really. But in a regime where there was fire maybe every so many tens of years, if you have your regeneration ability underground, when a fire goes across the surface, you can shoot back up again. Whether you be a shrub or a tree like sassafras, you don't really lose any ground. You're ready to go. And oaks are really good at responding to fire as well. But even in the absence of fire, this dynamic is still very important. These below ground adaptations are very important for nutrient poor soils, and that's what the upland forest has. That makes a difference from, say, the cove forest, where light is far more important because the soils are quite nutrient rich as opposed to here.
And you were talking about how really we need to have a more updated version of old growth, because old growth in some of these forest communities are old growth clonal networks, in a sense that could be centuries old or even older.
That's right. When you talk about the definition of old growth, what are you really trying to get at? I mean, it's very sort of, very simplistic to just go and measure the age of a tree and say that cutoff is has some magical ecological property to it, which it doesn't. What matters to a forest is whether trees are able to go through their natural life cycle, such that when that tree, like these trees around us, have fallen, the nutrients that are stored in the boles of these trees, that high concentration of calcium and potassium, that's allowed to get back into the system again and replenish the soil in a forest where the soils are very limited in those resources. The trees are big enough to create the gaps I was talking about, that allow the regeneration and the maintenance of diversity that is gap dependent in the forest. The actual age of that tree doesn't matter. It's the dynamics that the size of trees generate that would have happened naturally, in the absence of human interference. Is that happening? And you're right. I mean, this tree, it doesn't look very old, and it's not. The stem itself, this actually is probably quite old, because every angle on that's probably a year of growth. So this could be about 30 years old. But the root system and the original seedling that started this root system going could be hundreds of years old, hundreds. You come through here, you clear cut, and you eliminate and convert this forest, the sassafras goes away. You've eliminated century-old individuals. The blueberries, the maple leaf viburnums, the oaks that sprout in place for many, many decades before they shoot up. The actual ages of genetic individuals in this forest is far different than just a simple coring of a tree that's standing at this moment in time.